Good morning, student. Now in this lecture third, we see the linear and first shifting property of Laplace transform. Okay, that is the linear and first shifting property of Laplace transform. The learning objective of this lecture is, by the end of the lecture, student will able to first one apply linear property to find the Laplace transform of the function, and second one is apply first shifting property to find Laplace transform. Okay, so we see the linear property transform. It states as f of t and b, L of f of a into f of t plus or minus b into g of t is equal to a into L of f of t plus or minus b into L of g of t. Note that if in this property a is equal to 0, b is equal to 0 put, then we get the Laplace of 0, and always remember that Laplace of 0 is 0. So this is the statement of linear property of Laplace transform. So what is that? Whenever there is plus or minus between any two functions, and if we take the Laplace of that, so this property state separate the Laplace, and if we multiply any function by a, then we any function by a that is a constant, we take that constant outside and take the Laplace. So this is the linear property, and this is without proof for your syllabus. So student, here we see some examples. So first example, find Laplace transform of cos t. Student, see, whenever we want to ask Laplace transform some trigonometric identity such as cos square t, sin square t, cos cube t, sin cube t, sin a, cos b, cos a, cos b, sin a into sin b, and all, or some in hyperbolic. If such type of trigonometric identities are occurs in the example, then firstly write its formula, such as here we know that what is cos square theta is equal to, or cos square t is equal to 1 plus cos 2t divided by 2. So like in this way, since we take the Laplace of this cos 2t, cos square t is nothing but Laplace of this term, but this 1 by 2 take common, take the Laplace of this, Laplace of 1 plus Laplace of cos t. So separate it by using linear property. Why do so? By linear property, and therefore we know that Laplace of 1 is 1 by s plus Laplace of cos 2t is s upon s square plus 4. S 2 square means 4, and that is equal to 1 by 2 s 1 by s plus s upon s square plus 4, and therefore Laplace of cos square t is 1 by 2 into 1 by s plus s upon s square plus 4. So this is the answer of Laplace of cos square t. Now student, we see the another examples, that is find the Laplace transform of 4t square plus sin 2t plus e raised to 2t. So first of all, taking Laplace on both sides means Laplace of this is equal to, by using linear property, we separate. Why we separate and take common? Because of this is plus, this is plus. So when there is plus or minus, then we separate, and when we multiply any constant, take that constant outside, like in this way. This 4 outside, Laplace of t square plus Laplace of sin 3t plus Laplace of e raised to 2t. Why so? Because by using linear property, right? Now we know that what is Laplace of t square? That is 2 factorial upon s cube into 4 plus what is Laplace of sin 3t? It is 3 divided by s square plus 9 plus what is Laplace of e raised to 2t? It is 1 upon s minus 2. So therefore these two 4 the 8 by s cube plus 3 upon s square plus 9 plus 1 upon s minus 2. So this is the Laplace transform of the equation. This 4t square plus sin 3t plus e raised to 2t. Okay, student, now we see the another example, that is find Laplace transform of t square e raised to minus 2t plus cos hyperbolic square 3t. So here cos hyperbolic square theta. So first of all write down the solution. Laplace of this whole term means Laplace of this. So before solve this, firstly we write cos hyperbolic square x equal to 1 by 2 cos hyperbolic 2x plus 1. So use this formula. Here we get this one. And after that, this is nothing but after that we take Laplace of 1, Laplace of this, and in which, so this is implies for this term we write here this 1 by 2 into Laplace of 1 plus Laplace of cos hyperbolic 60, right? And this is equal to this Laplace of t square is 2 factorial means what? 2 factorial means 2 into 1, that is 2. So 2 upon s cube minus Laplace of e raised to minus 8 is 1 upon s minus a. So a is here 2. So since it is 1 upon s plus 2 plus 1 upon 2, this is equal to 1 by 2 into this 1 by s plus s upon s square plus 36. After multiplying side, it is 1 upon 2s plus s upon 2 into s square plus 36, right? So this term, and that is your answer. So student, we see the text here. Now it is somewhat different than earlier examples. How the Laplace transform. So it is a very simple, very beautiful example. See, to solve this, first of all, what we know that what is cos of x is. So we know that cos of x is 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial minus and so on. Now see, what is your x here in our problem? X is root t. So after that we find cos of root t. Root t means cos of root t is nothing but cos of t raised to half is equal to this term. Here x having value t raised to half, right? So 1 minus t raised to half raised to 2 means only t by 2 factorial plus t raised to half raised to 2, that is raised to 4 is t square upon 4 factorial minus and so on. So this is the series of cos root t. Up is now we divide this cos root t by root t. So dividing by this root t after dividing by root t, so means divide 1 by root t means it is t raised to half. So upar aane ke baad that is equal to t raised to minus half. So we get this term. Now taking Laplace on both sides, iska Laplace, it means that Laplace of this. So taking Laplace transform on both side, what do we have? See, we get this term L of cos root t upon root t equal to L of this means, and again remember Laplace of t raised to n is equal to gamma of n plus 1 upon s raised to n plus 1 if n is fractional, right? And remember another thing, gamma of 3 by 2 means another formula, that is gamma of n plus 1 equal to n gamma n. This is the property of gamma function. So using this property, we find gamma of 3 by 2. That is, it is 3 by 2 means 1 by 2 plus 1. That is equal to, this 3 by 2 can be written as this 1 by 2 plus 1. So n is this. So using this property, is 1 by 2 gamma of 1 by 2. And remember that one thing, that is gamma of 1 by 2 equal to under root pi. This is the formula. So it is 1 by 2 under root pi. It is the value of gamma of 3 by 2. Similarly, we find gamma of 5 by 2. That is equal to, it is gamma of 3 by 2 plus 1. What is this? Is nothing but 5 by 2 equal to 3 by 2 gamma of 3 by 2. Using this formula, gamma of n plus 1 equal to n gamma n. That is equal to 3 by 2. Again we write this 3 by gamma of 3 by 2 is this what? 1 by 2 under root pi. And therefore 3 by 4 under root pi. It is the value of gamma of 5 by 2. Similarly, gamma of 7 by 2 is equal to gamma of 5 by 2 plus 1 is equal to 5 by 2 gamma of 3 by 2. And what is the value of gamma of 3 by 2? This one. It is 5 by 2 into gamma of 3 by 2 is 3 by 4 into under root pi. So that is equal to 15 by 8 under root pi is the value of gamma of 7 by 2. Why we do so? Because why we do so? Because here we use this formula. Firstly, we use this formula. What is the Laplace of t raised to minus half? So C equal to t log t raised to minus half is gamma of minus half plus 1 upon s raised to minus half plus 1. That is gamma of half upon s raised to half. That is under root pi or 1, whatever the value. This is gamma of half plus s raised to half minus 1 by 2 factorial gamma of 3 by 2 upon s raised to 3 by 2 plus 1 by 4 factorial gamma of 5 by 2 s raised to 5 by 2, and that will be equal to this gamma of 3 by 2 and gamma of 5 by 2 written in this way, this and this. So in which that is equal to, from this we take common this gamma of 1 by 2 means under root pi, and from denominator we take common s raised to half. Means what is mean by it is under root pi, and this is s raised to means under root s, and this is nothing but under root pi by s. Means from numerator we take gamma of half outside, and from denominator we take s raised to half. So we have under root pi upon s into this term, and this term or this series is the series of e raised to minus 1 by 4s. If we expand this e raised to minus 1 by 4x, we get this series, right? So we have under root pi by s minus 1 upon 4 is the Laplace transform of e by and find the first Laplace transform of the following. First one is e raised to 2t plus 4 e raised to 4t cube. Answer is this. Second one, answer is this. Third one, answer is this. And to find the Laplace of this, use this formula. Cos is equal to cos A cos B minus sin A sin B. Third one, next. Sin 2t cos. So to solve this, use sin x into cos y is equal to sin x plus sin x minus y by 2. Use this. This is the hint for you. Then sin root t as earlier, right? So answer is this, and for which the hint is sin x equal to x minus x cube by 3 factorial plus x raised to 5 upon 5 factorial, and so on. Okay, student. So now we see the next article, that is first shifting property of Laplace transform. So see student, the statement of first shifting property. So if L of f of t is equal to f of s, then L of e raised to at f of t is equal to f of s minus a, and second is e raised to minus at f of t is equal to f of s plus a. So see student, whenever we multiply any function f of t by e raised to at or e raised to minus at, in that case only we use first shifting property, right? Whenever we multiply any function f of t by either e raised to t or e raised to minus at, in that case only we use first shifting theorem. How to use? We see for that some examples. Now this first shifting theorem or first shifting property is also without proof for you, right? So we take some examples, student. Here, find the Laplace transform of the following. First one is this: e raised to minus 3t, t raised to 4. The solution, student, first of all decide what is your f of t. Which is the f of t means what? E raised to at छोड़ के जो भी है, that is your f of t. और e raised to minus at या e raised to at छोड़ के whatever the value, that is your f of t. So first of all decide your f of t, take the Laplace of that. So f of t is equal to t raised to 4. So taking Laplace of that L of f of t, that is equal to this. So this is the Laplace of f of t, that is 4 factorial upon s raised to 5, right? So after finding the Laplace of f of t, this is the Laplace, and this is say f of s. This is the f of s. The Laplace, what is the f of s of? This is the f of s of t raised to 4. So after finding f of s of this f of t, then write by first shifting theorem. What is the first shifting theorem statement? L of e raised to minus at f of t is equal to f of s minus a. Means whatever your f of t, take the Laplace of that, and in that Laplace, that s replaced by s plus a, and therefore L of e raised to minus 3t t raised to 4 is equal to, what is the L of t raised to 4? This value, in which where your f of s, this s, that s should replace by s plus 3. If we multiply this t raised to 4 by s minus 2t, then it is s plus 2 4 raised to 5. If we multiply this e raised to minus 5t, so s plus 5 raised to 5, and so on, and this is equal to answer. And this 4 factorial is nothing but 4 into 3 into 2 into 1 divided by s plus 3 raised to 5, means 24 divided by s plus 3 raised to 5. So this is the answer, because 5 factorial means 5 into 4 into 3 into 2 into 1, like in this way. So the next problem, find the Laplace transform of this. Solution, we find, let's see the solution. First of all, what is f of t? F of t is cos 2t. So find Laplace of cos 2t, and we know that what is the Laplace of cos 2t? That is s upon s square plus 4. Due to we multiply this cos 2t by e raised to minus 3t, so by first shifting theorem, that is L of e raised to minus at f of t is equal to f of s plus a. Means what? L of e raised to minus 3t cos 2t is equal to, this is f of t, and the Laplace of this is this s upon this. Now yes is here as well as here, so should that s replaced by this s as well as this s should replace by s my s plus 3. So it is s plus 3 divided by s plus bracket square plus 4 and to s plus 3 upon s upon that is equal to okay s plus 3 upon s square, expand this, plus 6s plus 9 plus 4, and that is equal to s plus 3 divided by s square plus 6s plus 13 is the answer. Okay, so see, now next example, find the Laplace transform of this. 1 minute. Find the Laplace transform of t plus 1 whole bracket square e raised to t. Solution is, first of all, decide f of t. F of t is what? T plus 1 whole bracket square. So taking Laplace of t plus 1 whole bracket square. But firstly expand this t plus 1 square, that is t square plus 2t plus 1, and that is equal to Laplace of t square plus 2 outside Laplace of t plus Laplace of 1. Right, and therefore what is Laplace of t square? 2 factorial upon s cube plus 2 upon s square plus 1 by s, and this is the Laplace of t plus 1 whole bracket square. Now we multiply this t plus 1 whole bracket square by e raised to t. Due to that, we use first shifting theorem, and the statement of first shifting theorem is L of e raised to at f of t is equal to f of s minus a. Means whatever your f of t and what's its Laplace, in that Laplace that s should replace by s minus a, and therefore Laplace of t plus 1 whole bracket square e raised to t, that will be equal to 2 divided by s minus 1 cube plus 2 divided by s minus 1 square plus 1 divided by s minus 1. All these three s should replace by s minus 1, and that is your answer. Student, see next example here. Find the Laplace transform of e raised to 4t sine cube t. Now see, again this is trigonometric identity. First of all, what we do, we know that what is sine 3 theta is equal to, implies, take this here and this one here. So we have 4 sine cube theta is equal to 3 sine theta minus sine of 3 theta, and therefore what is sine cube theta? Transfer this 4 out this side, so it is 1 by 4. It is 3 sine theta minus sine of 3 theta. So this is the formula for sine cube theta. So using this formula we find sine cube t is equal to 1 by 4 Laplace of 3 sine t minus this, and that is equal to what? It is 1 by 4 into 3 outside Laplace of sine t minus Laplace of sine 3t, right? And that is equal to this 1 by 4 outside or multiply inside. After that, it is 3 by 4 s square plus 1 minus 3 by 4 s square plus 9, because Laplace of sin t is 1 by s square plus 9. Laplace of sin 3t is 3 upon s square plus 9. And this is the f of s of L of sin cube t. Now we multiply this sin cube t by e raised to 4t. Due to that reason, we use first shifting theorem, and which state as L of e raised to at f of t is equal to f of s minus a. And in this, so what we do, hence L of e raised to 4t sin cube t means whatever the Laplace of this sin cube t, this one, in which where your f of s is there, that s should replace by this s as well as this s replaced by s minus 4, and that will be equal to, after calculating, what is this, is the expansion s square minus 8s plus 16 plus 1. This is s square minus 8s plus 16 plus 9, and what is 16 plus 1, 17, 25. So this is the answer. Yes, this is a very, and that is up cross multiplication. We have minus 7 divided into s square minus 8s plus 20. Now student, next example, and these are some formulae direct. When we multiply sin bt by e raised to at, right, means actually see what is the Laplace of sin bt, it is this b upon s square plus bt, and then if we multiply a raised to, so that s replaced by s minus a. Similarly, this is the example, means sin 3t multiplied by sin 2t. So first of all, write the Laplace of sin 3t is 3 upon s square plus 9, and in which that this should replace by s minus 2. If you multiply by cos 80 by, this is s replaced by s minus 1 is here 2, so s minus 2. Similarly, like in this way, we multiply all this and we get the answer. Also there are some also examples. See, these are some also standard formulae by using first shifting theorem. Okay student, now there are some two examples, or find the Laplace transform of this e raised to 3t sin 4t plus 3 sin 4t. So take first of all, let f of t is equal to what, this one. Then take the Laplace of this. F of t means Laplace of this. We know that Laplace of cos 4t, that is s upon s square plus 16. Laplace of sin 4t, 4 upon s square plus 16, right, and that is equal to s upon s square plus 16 plus 14, 3 into 4 is 12 divided by s square plus 16. So this is your f of s, and therefore this is your f of s, Laplace of this. And we multiply this function by e raised to minus 3t. It means that whenever you use any function by e raised to something, in that case we use first shifting theorem, and which state as L of e raised to minus at f of t is equal to f of s plus a, and therefore that is equal to L of e raised to minus 3t f of t is equal to e raised to minus 3 cos of this 40 plus 3 sin 40, and this will be equal to, write down the Laplace of this, and here s replaced by s plus 3 because we multiply by e raised to minus 30, means this s as well as this s should replace by s plus 3. So we get this 2, and after calculating expanding this 2, we get this, and what is this 2, that is equal to this one, and therefore Laplace of e raised to minus 3t cos 4t plus 3 sin 4t is equal to s plus 3 upon s square plus 6s plus 25 plus 12 upon s square plus 6s plus 25 student. So this is the answer. Now we see the last example of this first shifting property, that is e raised to 4t Sine cos t. So remember, or it can be written as find L of this term. So first of all, find Laplace of sine 2t cos t. But remember here, this is the trigonometric identity. We can't find direct Laplace. First of all, we know that sine A into sine B is equal to sine A plus B plus sine A minus B divided by 2. So using this property, we have find taking Laplace of this L of sine 2t cos t means L of sine 2t plus sine 2t minus t by 2, and that is 1 by 2 take outside. Laplace of this sine 3t plus Laplace of t. After separating and taking Laplace, so we have 1 by 2 3 upon s square plus 9 plus 1 by s square plus 9. By using the Laplace of sine 3t is 3 upon s square plus 9, and Laplace of sine t is 1 upon s square plus 1. So this is the Laplace transform of sine 2t into cos t. Now we multiply this sine 2t into cos t by e raised to something. So by first shifting theorem, e raised to at f of t is equal to f of s minus a, and therefore Laplace of e raised to 4t sine 2t cos t is 1 by 2 Laplace of this term, and this term should, in which yes, this yes as well as this yes replaced by s minus 4, and therefore this is s minus 4, this is s minus 4. Okay, so and expanding this, it is s square minus 8s plus 16 plus 9. Similarly, s square minus 8s plus 16 plus 1, and therefore we get 1 by 2 3 upon s square minus 8s plus 25 plus 1 upon s square minus 8s plus 17, and therefore Laplace of e raised to 4t sine 2t cos t is equal to 1 by 2 3 divided by s square minus 8s plus 25 plus 1 divided by s square minus 8s plus 27. So this complete the examples of first shifting theorem. Now there is some exercise to you, student. Find the Laplace transform of the following. So first, t cube e raised to minus 3t, answer is this one. T plus 2 square e raised to t, answer is third one is 2t sine 4t, answer is this one. Then cos 2t sine t, sine 3, this one. This way, the last answer is this one. So this is about the first shifting theorem and linear property. So thank you, student, for today's lecture. So we see next article in next lecture. Thank you all.